Hello friends, Gaussian mixture model. So in this video we will learn about GMM, that is Gaussian mixture models. So before knowing that what is Gaussian mixture model, first you must know about what is mixture model. So let's see what is mixture model. A mixture model is a type of probability density model where we assume that the data is governed by a number of component distribution. So you can assume that in your data set, the data is governed by a number of distributions. And if these distributions are Gaussian, then the model becomes a Gaussian mixture model. So your data is governing by number of distribution, component distribution. And if that distributions are Gaussian type, then the model will be your GMM. These component distributions are combined in order to provide a multi-model density function which becomes a mixture model. So this was your mixture model, and they are depend on the type of distribution. What type of distribution is governing your data? Okay, so that was your Gaussian mixture model definition. Now let's look at an example, that is a real world example. Suppose we want to model the shopping habits of all the people in South America. Now you know South America is a continent. So one way to do it would be model the whole continent and fit everything into a single model. But we know that people in different countries shop differently. So we need to understand how people in individual countries shop and how they behave. So, to model the shopping habits of all the people in one continent, we have to take in account the different behavior in different countries present in that continent. We can't create one complete model of continent. We have to take account the all the variations in your different countries present in that continent. So what we will do now, if we want to get a good representative model, we need to account for all the variations within that continent. So that is our requirement, basic requirement. In this case, we can use mixture model to model the shopping habits of all individual countries and then combine them to become a mixture model. So that is your mixture model. You can see that real world example, and now you have understand that what is mixture model. So this, in this way, we are not missing nonsense of the underlying behavior of individual countries. So that is your mixture model. We have to take an account all the variations within that continent. By not enforcing a single model on all the countries, we are able to extract a more accurate model using that mixture model. So that was your mixture model. Now what is GMM? GMM is a parametric model represented as a weighted summation of component Gaussian functions. Now what is GMM? It is a parametric model that can be represented as a weighted summation of component Gaussian function. We assume that the data is being generated by a set of Gaussian model that are combined in some way. GMMs are very powerful and are used across many fields. So we will combine the data which are generated by a set of Gaussian model, and that will become your Gaussian mixture model. So that's why its name is mixture model, because we are combining different Gaussian model to form a complete one Gaussian mixture model. Okay, these are applications of GMM. So what are applications? Image database retrieval, modeling stock market fluctuation, and biometric verification. So these are the applications of GMM where we are using Gaussian mixture model to implement these examples. Now let's see a program in which we are creating a Gaussian mixture model for a dataset using Python language. So we are creating a classifier using GMM, that is Gaussian mixture model. So let's see that example.